Okay, welcome back. Happy Wednesday. Today, class number 39 is our last day of new material for the entire semester. We are going to cover equations that include algebraic fractions. We'll be using our same completing the denominator technique that we've seen the last few classes. On Friday coming up is our fifth and final quest. That quest is on all the materials since the test, that is to say, the 4 classes on algebraic fractions, including today's class. Then Monday is our review day. That'll be our last class of the semester. Tuesday next week is the last day of the semester, but of course we don't meet Tuesdays. And then Wednesday, 1 week from today, is a final exam, 8 a.m. right here in this room. Questions on the calendar? Okay, so I said we're starting on page 84, but I just want to jump ahead for a second to the sample quest problems. Oh, I don't think 84 was the right page. 88, thank you. But I want to jump to the sample quest problems for a second. So I sent this email out to people, but I don't know if everybody's checking their GCC email regularly. But you know, I promised that there are videos for these problems, and Megan sent me an email yesterday. Hey, for some reason I can't access the playlist that exists for this set of problems, which was weird because she did access the playlist like 2 days ago and it worked just fine then. And this is totally my fault, but I've been in spring preparation mode, and I've decided to kind of revamp how I present these practice materials, and instead of having them all interspersed through the packets, I've made one large set of practice materials with all the problems for the whole semester. And as such, I've renamed the videos, and I've deleted some playlists and made just one master playlist, completely forgetting the fact that you guys might still be wanting to access those videos. So I will say that even if the video titles have changed, you can still search for the titles that I said. So 106 sample quest 5 problem 2 will pull up exactly the right video that will show you how to solve problem number 2, which is that guy right there. So I've pulled it up over here on YouTube. I typed in 106 sample quest 5 problem 2. The very first thing says something slightly different, and it's problem 50, but take my word for it, that's your problem 2. I've renumbered things, but YouTube will pull up the correct video, okay? And there is now one massive playlist, which goes from number 1 to number 54. But again, these problem numbers, they don't mean anything to you, although they're exactly the same problems that were in these sample problems that you've got in front of you. So the best thing to do, like I said, is search for the exact title of the thing that you are looking for, okay? Because the problem numbers have changed, but the title search will still work. Any questions about that? Okay, many thanks to Megan for catching that. Okay, so let's go to page 88, and we'll start at the top with the summary. Lydia, daily summary. Thank you. Tara, number 1. Thank you. So we're going to solve 2 examples together here, A and B, and then you guys will do lots of practice in the activities. Before I do that, I did have one other quick announcement. It is still possible to register for the spring semester, and I know many of you have already registered for the spring, but I will tell you that as the January break moves along, classes tend to fill up, and waiting until the last minute to register is a good strategy for getting stressed out when you come in to register, because the core courses that many of you require are the same core courses that many other students require. And you know, like I always register people 2 or 3 days before the semester, and it's just like pulling your hair out, which is why I have no hair. So I encourage you to take this opportunity to get registered before that, you know, like right before spring semester crunch. Like that last week is not when you want to be registering. So, so go meet with your academic advisor. If you don't know who that is, ask me. I'll tell you right after class. You could certainly go to the Academic Advising Center. They are here during the January break, whereas a lot of your advisors might not be here. But go ahead and get registered so that you don't have to deal with that stress. Okay, so let's take a look at part A. So the first step here is exactly the same as the first step before. It's to factor those denominators completely. So let's factor the denominators. So the first denominator is just 1 over x. I'll leave it there, but I'm going to make that division line real long because I'm going to be completing that denominator, right? So we got some empty space here to fill in whatever we need. Equals. Okay, upstairs there's an 8. What can I factor out downstairs? We'll take out that 3. So 3 times 2x plus 1. And then again, make that division line long. And so now in a different color, we're going to complete the denominators so that they turn into each other. So let's start at the second one. What is this denominator missing? X, right? So I'm going to put an X right down there, and therefore also put an X right upstairs. Top and bottom by the same thing. And then we look at the first denominator. What is it missing? 3 times a 2x plus 1. 3 times 2x plus 1. And so by the way we've built this, what do you notice about the denominators? They're the same. That's what you did. You made them the same. All right, so here's the twist. It used to be we were adding and subtracting these things, and we would then make one fraction with that denominator. But this is an equation, and when you have an equation, you actually have a little bit more freedom. You have one more tool in your arsenal, and that's to do the same thing to both sides of the equation. We didn't have that tool before when we were just adding or subtracting things. So here's the thing that we are going to do to both sides of the equation. We're going to multiply both sides of the equation by exactly the right thing to make our lives better, and the right thing is that common denominator. And so I'm going to write this step here, and then I'm never going to write it again, and you don't ever have to write it, but we're going to multiply both sides by that denominator, 3, 2x plus 1 times x, and then I'll squeeze this in up here. So we're multiplying both sides by the common denominator. So that's definitely legal because I did the same thing on both sides. And here's the point of doing that is that as soon as you do that, you get this massive explosion of canceling, right? That 3 cancels, the 2x plus 1 cancels, the x cancels, and the right-hand side no longer has a denominator. Fiona? You can, I guess. Yeah, it's the same. Yeah. What's that? That's right, neither side has a denominator because on the left-hand side, this entire thing that we put, you put it there for the sole purpose of getting rid of that entire denominator. And so if we write down what's left, we'll have a much simpler equation that has no more denominators. So 1 times 3 times 2x plus 1. That was what was upstairs, mostly in red. What's the next symbol I'm going to write? Equals. If it was an equation before, it's still an equation. And the only thing on the right-hand side is 8x. So there are 2 key takeaways from today, and that was one of them. Once you get that common denominator, once you get it to agree, multiply both sides by that denominator, and all the denominators cancel. And that's the step that I said I'm not going to write down ever again. I'm just going to say, oh, okay, I've got these 2 fractions here with the same denominator. It's like the denominator doesn't even matter. Just get rid of all of them at the same time and just copy those numerators. And so now I have an equation that honestly looks like some of the equations we solved on the first day together. And this is really easy to solve, right? The new thing is getting rid of those denominators. Iman? So cross multiply is a perfectly valid technique when you have fraction equals fraction, which is what we had. Cross multiply isn't going to get us anywhere in part B. So I'm just trying to teach one thing, even though you're right, cross multiply might be a tiny bit more efficient than what we did in this particular example. Okay, so let's solve this one. So we'll distribute the 3. 6x plus 3 equals 8x. And then we'll subtract the 6x. And then finally, divide by 3 or 2? 2. So we get x equals 3/2. Okay, so I said there were two keys for today's idea. One of them is to multiply both sides by that LCD and they all cancel. The other one is right here. Typically when you get x equals in an algebra problem, you stop, you're done. And you know, like if you have time, you check your answer, right? Just to make sure you didn't make any mistakes. But it turns out when you're solving equations with x's in denominators, it's possible that the x equals 3/2 that we got isn't an answer, even though we did everything right algebraically. So we have to check whenever we have one of these kinds of equations. So let's do our check over here. So we're going to take the original equation, go all the way back to the original, and we're going to change all those x's into 3/2. So 1 divided by 3/2 equals 8/6 times 3/2 plus 3. Okay, so every x became 3/2. There's an equal sign in between. I'm going to add a question mark. I don't know if it's equal. That's what we're checking right now. Okay, we know taking 1 and dividing it by a fraction has the effect of flipping that fraction over, right? Reciprocal. That becomes 2/3. Equals, again, question mark, 8 divided by. Okay, 6 times 3/2 is 9. 6 times 3/2 is 9. It's 1.5 sixes. So that's 9 plus 3. And then our last step here, 2/3 equals with the question mark. 8 divided by 12. Does it? Yes, it does. So x equals 3/2 is our answer. Questions on that? Okay, so let's try B. Same idea. What's the first step? Factor. Always factor those denominators. So first guy doesn't even have a denominator at the moment, so I'll put in a 1 and I'll leave a blank space over there. Plus 4 over, can we do anything with x minus 2? No, there's nothing to factor there. We'll just leave some blank space. Equals 8 over, take an x out. And what's left? X minus 2. So we factor all the denominators, and now we're going to build the LCD by completing everything to what it's missing. Okay, so you can start anywhere you want. This is like an organic process. I'll start in the middle. X minus 2. Looking to the left, I just see a 1, so there's nothing to, the x minus 2 isn't missing a 1. What is the x minus 2 missing on the right? Is an x. So I'll put an x here, and also therefore an x upstairs. What do you notice about the last two denominators now? They're the same. Okay, so then all we have left to do is build the last guy. So what is this guy missing? X and x minus 2, right? It's missing the whole thing. So all those denominators are the same now. And so one of the two key ideas from today is at the moment you have all those denominators the same, what do you do to both sides? Multiply by that denominator, and the effect is they all disappear. Every single denominator disappears here. So we're just going to write what was upstairs. 2x, x minus 2 plus 4x equals 8. So much easier. Okay, so that's basically just reading the denominators straight across. All those numerators disappear. All right, we'll distribute here. 2x squared minus 4x plus 4x equals 8. So 4x's cancel, so we get 2x squared equals 8. We'll divide by 2. X squared is 4. And then square root both sides. How much is x? 2. Any other value of x that satisfies that equation? Negative 2 also works, doesn't it? When you take negative 2 and you square it, you still get positive 4. It's really easy to miss that plus or minus coming in. I'll give you an alternative here in parentheses. If you had decided to get a 0 on one side, which is a standard thing for quadratics, you could then factor the left-hand side. How does x squared minus 4 factor? X plus 2, x minus 2. And then you see the two of them, right? Okay, so our solutions here, x equals 2, x equals negative 2. And again, the second important thing for today is that for these kinds of equations, you have to check your answers. So you could check x equals negative 2. And I'll just let you do that one later on if you want to. I'll tell you that it's going to work. Now let's focus on x equals 2. Let's check that one. So we're going to plug that thing back into the original equation. All those x's become 2's. So going all the way back here, so I'm going to squeeze this in up at the top. We're going to check x equals 2 into this equation right here. So it would say 2 plus 4 over 2 minus 2 equals 8 over 2 squared minus 4 times 2. Question mark on the equals. 2 times 2, thank you. Question mark. And what's the problem here? We're dividing by 0. So that equation is just not true. And so even though we didn't do anything wrong, x equals 2 pops in here as an extraneous solution. It's an extra solution. It appears to be a solution, but it isn't. X equals 2 does not make that equation true. So that one, nope, that one doesn't work. And so coming down here, I'll just write the word reject on this guy. X equals 2 is not a solution. X equals negative 2 is the only solution. Okay? So this is why we have to check our answers on these kinds of problems. If you have x's in denominators, you got to check your answers. Okay, so I'll put this back up. I'll come around and check homework in a little bit, but get started on the activity on the next page.